Okay, guys, hope you can see me and you can hear me. Um, can you hear me? Please respond in Discord. Okay, cool. So, well, I guess Clara, Hugo, and Yang already welcomed you. Welcome from myself. I'm Status Vitalis, and I'm here to teach you about GitHub. Um, well, Git, and I'll explain later. Okay, so um, two things. The first one is um, we are going to try to do this kind of interactively. I'm not sure how this is going to work. And yeah, I guess it's a bit awkward, 2020. But I hope we make it work nonetheless. Um, Please don't hesitate to make any questions on the Discord. I'm going to have it open here. And you can interact with me anytime you want. And well, I see someone is connected to the voice channel. We're not going to use that, at least not today. So we're going to do this course in two classes. One is today with the introduction, let's say, of the theory of Git and some basic things you can do on your own, on your computer. And then we are going to have on Friday, like the last bit, which is more about how to interact with others. Yeah, I hope that makes sense. So, uh, before we start, I want you to tell me if you know what GitHub is. Yes, no, have you heard it before? No, yes, no, yes. Okay, good. Um, that's a lot of yes. That's pretty cool, actually. So, um, cool. So, those of you who know what GitHub is, can you tell the difference between Git and GitHub? Okay, everybody says so. No, okay, that's okay. That makes sense. It's a confusion that happens to most people. So, for those of you who don't know what GitHub is, okay, Pratyush knows. That's good. That's actually the correct answer. So for those of you who don't know what GitHub is one platform which has exploded the last 10 years or so and has been used by software developer programmers or even from other people like data scientists and stuff to share information to share mainly software source code, but sometimes it's used for other stuff like it could be used, for instance, to host data or maybe even to share common files between people. So maybe we could show a bit how does it look. I guess you see my screen, hopefully. So GitHub is this web page where people have different projects. Like this is one of the projects where we host, for instance, a QGIS plugin for CityJSON. It's a tool that we develop. And those are basically the files that we want to keep the history of. And you have the ability to see the history of how the project has evolved. So you can see how me, in this case, have made several changes in the past, in July, in May, in February. My colleague Anna here has also made a few commits. So we know when we made changes to the project, and we can see specifically for every change what we changed, right? So in this case, for instance, I selected a specific change where I added some metadata for the release of this plugin. So that's GitHub. It's a web page basically, and then you can have different projects, you can host them all, and different people can exchange the information through that. Okay, that's GitHub. Now, Git is the engine that runs GitHub, and GitHub is not the only platform that exists out there. You already know GitLab, for instance, from the source code that you downloaded yesterday for the statistics that you run. GitLab is a similar platform to GitHub. They all do the same thing. Well, have you noticed what's common between them? It's Git. So, well, Git is the software that does store all those changes. So it's a software where I can have, let's say, a folder where I have my project, and I can make changes to the project, and I can, every once in a while, I can tell to the software, well, now I want to save the changes and add a title and a description, and it will remember who I am and when I made these changes, and then I can share those changes with other people. Okay, so hope that makes sense. So I guess you should be seeing my presentation now. Sorry, that's the first time for me, so I'm not sure how it works with the new tools. It's fun. So anyways, let's start with some theory. We're gonna start with version controls in general, because Git is not the only one that exists, but just some basics so you can understand pretty much what I said, maybe a bit more thoroughly. And so we're going to say why we need version control, what is it, and the different architectures, what are commits and what are branches. So those are the basic things that you need to understand in the conceptual level. And then we're going to go specifically to Git, and I guess we're going to have our hands on. Now, before that, there's something that we left kind of in the middle yesterday, I think. So I think for the preparation of the yesterday's class, you had to download, you had to install Ubuntu or the Windows subsystem for Linux. I'm not sure if you did. Yesterday we had this discussion that you could do these things through PowerShell. I would strongly advise that if you want to use Git, because today we're going to use it through terminal. I suggest that you use Windows subsystem for Linux if you have Windows. If you have Mac OS or Linux, I guess you're already kind of familiar with the terminal and how, well, most of the things that you want to do, they're already there. I think Git should be there, all the tools that we're going to need. But for Windows, if you don't solve Windows subsystem for Linux, it's going to be a bit more complicated, not specifically for today, but for Friday. Because we're going to have to do some change with GitHub server, and in that case, Windows is sometimes a bit complicated. Now, if you don't have Windows subsystem for Linux, for today at least, you can go to git-sem.com, which is the official page of Git, the software, and then you can download it from here for Windows. And I guess for today, you can use it from PowerShell, or there's actually when you install it in your computer, you're going to have an extra option, which is, I think it's called Git Bash, and it's going to add a window which is going to work out of the box. So I'm going to leave it here for like a few seconds. You visit that page if you have Windows. Otherwise, well, we can always troubleshoot in the process. Okay. So let's go to the theory, the boring stuff. So versioning collaboration. So why do we need versioning? Well, it's useful because you can track the history of your work. So imagine if you work in a project for months or even years, you cannot really remember what you changed when. And it's really useful to know what you changed when, because many times you can introduce bugs or you can break things, or you want to remember why you did something and it's not clear. And with version controls, we can do that because when we make any change, we kind of document it with some kind of description, and therefore we can then come back to it and look at it and understand why it works. So it allows us to work as a team. I always like to do this comparison with something like Dropbox or Google Drive or whatever cloud storage you might be using when you're doing some assignment, for instance, as a team. And well, in that case, what you do, I guess, if you have, let's say, a shared folder with Dropbox, if you've done so before, well, I guess everyone has a folder. You change things, they instantly change. Other people are aware. That's kind of cool. But there's a problem. I mean, if you change the same file, let's say both people change the same Word document at the same time, if we leave aside any kind of special tools that might exist for Microsoft Word, for instance, specifically, well, most of the times we have a problem. I mean, someone makes a change, someone else makes a change simultaneously, and the system kind of doesn't know what to do, doesn't know how to incorporate the changes. Version controls are kind of like more clever than that, in the sense that they can, if we don't make the exact same changes, both people at the same time, then it's fine. We can change the same file if someone changes the top, the other one changes the bottom. It's fine for version control systems. They can just merge those changes because they are aware that we didn't change the exact specific lines of the same file. And then the third benefit is that we can manage the project that's not specifically to Git. That's basically the additional functionality you find in things like GitHub or GitLab, where Git is specifically about storing the versions and seeing who changed what, etc. But modern platforms such as GitHub and GitLab, they give you some additional tools, like you can have issues where people can report issues for you, or you can make issues as note for yourself, and then you can refer to them. You can have some small kind of project management. You have the ability to easily fork. We're going to exchange what that is on Friday. So you can basically take one's project and make a copy of that, so then you can make your changes, and then if you think that the original author might care about your changes, then you can make what is called a pull request and basically inform them that you have made some kind of improvement in their code, and then they can just incorporate it in theory with a click of the button. Those things are all on top of Git, made from GitHub and GitLab. Okay. So in your case, I guess, well, I've already heard that many of you have some experience with programming, which is good, I guess. And if you have experience with programming, you'll find it very useful, especially if you work to something like software development. Because, well, software development is so intense and you have to share the changes with others all the time, and it's really hard to keep up with who changed what, and then it's really hard to understand what you did. And with all those information about the history of the project, you solve a lot of the issues. Even if you're working yourself, you can use versioning, because that way, when you leave a project and then you catch up like 3 or 6 months later, let's say, you don't really remember necessarily what you did, so you can go back to the last few versions, like where did I leave this project? And if you find something that doesn't make sense, you can always look up when did you add it, and then you can find the description of why you did it. Okay, so I hope that makes sense. Another I think in your case, it's going to be used also for submitting assignments. So it's going to be, well, mandatory to use it. So good luck with that. I'm always available for help. So we also have a dedicated chat for that. So don't hesitate to ask any questions for that there. So version control systems in general. So Git is only one subsystem for keeping versions. Any version control is basically the management of changes, documents, computer, and program. Okay, that's just a description. So the bottom line is like we have many different systems like Git. Every system has pretty much those two components. We have what we call a repository, and we have what we call a workspace. So the workspace is basically, let's say, the folder which contains your project. You have a folder, you have your files there, whether it's Python folder, it could be a LaTeX project, it could be anything. It can have data, Jupyter notebook, whatever, right? And you want to keep track of the changes of those files. The current state of those files is called pretty much the workspace, the actual folder of that. The repository, you can think of it as a big bucket when every time you want to keep a snapshot of your workspace, you just ask the system to take a snapshot and put it inside the bucket. Okay, so based on that, we can have two types of version control systems, centralized and distributed. Centralized is the more simplistic approach. So you have one repository, which is somewhere hosted in a server. Let's say that could have been GitHub, kind of. And then so that's the big bucket where you keep all the history and the versions and who did what, etc. And then your workspace is in your computer. And then when you make a change, you ask the system to make a new snapshot. And you ask the system, takes a snapshot and push it to the central one and only repository. Okay. You might have heard of those. I'm getting older. Every year you're younger. I mean, compared to me. So maybe nowadays you haven't heard of any of those, but Subversion is one of them. Microsoft Team Foundation Survey is another one. CVS is like really old one, probably one of the first ones. Those are all centralized, and the idea was like that. You had one repository somewhere hosted, and you would always have to communicate with that in order to submit a new version. Now, distributed was like, I would say, a more modern approach. Git and Mercurial are a couple of them. And the idea of distributed systems is that you don't have one repository, which is the absolute truth of over there. It's actually that every individual person that is involved in this process has its own repository. So instead of having one absolute truth, as I said before, and always communicating with us like, can I submit this version? And then the absolute truth will tell you, yes, please give me that version, tell me what you did, etc. You have one local in your computer, you have a repository, and that repository, you keep updating with new versions, and every once in a while you can exchange those versions with other repositories. That's the idea of distributed. Okay. So this is how centralized architecture is, as I said before. So this is a repository, the orange thingy, the one and only truth, and the different users only have a workspace, so only have their folder, and every time they want to send something, I believe there's a way to highlight. So, no, that's cool. Should have been more prepared. Never mind. So every time they want to add a new version, or every time they want to get information about the history of the project, every individual user would have to communicate with the server. Okay, that effectively means every time you want to submit a new version, every time you want to see the history of your project, you have to have an internet connection so you can connect with wherever the server is. Okay, that was the era of centralized systems. That has become more and more obsolete because it had certain limitations. It's easier to deal with at first, but eventually, as systems become more and more complicated, it doesn't work that well. So, especially if you actually do some interesting stuff that version control systems are meant for. So distributed systems became a thing. And the difference is, as you saw before, if you see the difference, is like before we had only one repository, the orange thingy, and every user only had the workspace, the folder. But now every individual user has their own repository themselves. So the idea is this is your folder. Let's say this is a Python project, and you want to make a change. You're at a certain point, and you make your change over here. And when you're ready to submit the change because you fixed a bug or something, then you notify your repository. You use Git locally, and then you say, I want to submit a new version. And then you type your description, you say what you changed, etc. And then that's it. Now that's a new snapshot of your project. But it's only in your computer, this thing, right? Nobody else knows about this version. Now at this point, you can either keep adding more and more versions until maybe you finish a bigger, more significant change than the smaller one that you might have submitted. And then when you're ready to share all the changes that you've done with the world, let's say that this is a big feature you have been working for the last few days, and now you want to share it with the rest of the people, then you can do what we say push to GitHub, let's say. And that's when people will actually see that you changed something. And then they can download the changes in their own repositories and keep working with that. That's more or less the idea. For today, we are going to only work with how you communicate with from your workspace to your local repository. And on Friday, hopefully, we will do some push and pull, so we will just exchange information to the main server. Hope that makes sense. Are there any questions so far? I'm gonna wait like 10 seconds. No one is typing. It's not that early. You're not sleeping, so I guess you just don't have questions. So how does it look like, this repository, this big bucket? You can think of it as like a line. That's, oops, Chris wants to say something. No, they don't. You may speak. Okay. Goed. So most of the times you can think of a repository as a simple line where you have commits one after another. Commits, we say the snapshots in our terminology in this case. Well, different system has different ones. We will stick with commit because that's how Git calls them. So every single of those things, those little circles, you can think of them as one snapshot of your project in time. And the line basically shows the evolution of your project, right? Commit 1 came first, commit 2 came second, and then 3, and then commit 4, etc. Of course, you're going to have some more interesting information there, like a description of what you changed and who changed it and what's the time of the change and stuff like that. But the idea is that you have this linear evolution of your project, and then you can keep track of it. Now, it seems like it, but to be fair, that's not what it actually is. What it actually is more like a meta network. Because, well, if you were the only person working there, and if you weren't doing anything sophisticated, yes, you would change something, you would submit a version, you would change something, you would submit a version. But if you either collaborate with others or if you want to experiment with things, then what you create eventually is this more metro-like network, as I said before, where basically you can have those diversions like the red line over there at the bottom. And that probably means that, for instance, this was the initial state of the project. Someone changed something here, someone changed something after the last commit. And meanwhile, either this person or some other person maybe also changed something without being aware of this change. Okay. Now the other person that is working on the blue line still did something over there. So at this point, if I'm here, I don't know anything about this change. And if I'm here, I don't know anything about that and that change. And what's super cool about the version control system is that at any point, I can just say, well, you know, one person did that, another person did that and that. Please merge everything into one, and we end up there. So in that specific case, if you haven't changed exactly the same thing, exactly the same line of the exact same file, this is going to work out of the box. I mean, if you have a Python file with multiple functions, and let's say this person changed something here in one function, here in another function, and the other person changed something in the third function, that's going to work out of the box. The version control system is clever enough to say, well, they didn't change the same function, I'm going to merge it. Okay? That's the idea. So version control systems, and more specifically Git, is a bit of complicated. Many people are intimidated or overwhelmed by its, let's say, complexity. Well, that's the downside, but to be honest, I think if you understand the internals, then things can become quickly very easy. And the internals is, I mean, the swap I think you have to make in your mind, if you had any idea about how it is before, is that it's not this linear thing where it evolves from the odd to the last commit, and it's not linear. You have to think of it as a graph, and more specifically how it's called, it's directed acyclic graph. And here's an example of what that looks like. We have one commit which is called A. It's over here. We have another commit, it's called B. That's the second one. Then we had another one which is C, and the other one which is D. This is the notation I'm going to use in this course. And I guess you will find it counterintuitive that while we progress in time forwards like this, I mean, like right-wise, the arrows are actually pointing the other way around. This is because that's how things are stored internally, right? So someone makes change, the first commit here, this is commit A. Someone else makes another change, and that's B. Now, it's not that A knows that B is the next one, it's that B knows that A was the previous one. Okay, so those little nodes are called commits or revisions, and it differs from system to system. In our case, they're called commits. And every commit, the only thing that they need to know is what was the previous one. What was the one upon they built? Okay, so what was the previous state, and what are the changes that I just made in this commit? So how do those commits and revisions look like? I think I gave you an example before, because of course the pages might be overwhelming at the beginning. But basically every commit or revision, every snapshot, you want to call them as you want, commit is the terminology in Git again. It will have an ID. In the old centralized system, that would have been just an incremental number. For instance, it's a version. The first version would have the ID of 1, the second one would have the ID of 2, etc., etc., etc. Of course, you understand that the problem is this makes this idea of a linear evolution, which, as I explained before, it's kind of misleading because eventually you will have some kind of a tree and it's not clear. I mean, if we go here, for instance, if that's 1 and if that's 2, then is that 3? And then is that 4 and is that 5? But how does it work, right? So that is kind of misleading. So commit uses another way of IDs, kind of like random IDs. Not truly random, but we will explain later on. So every commit has an ID, it has an author, so it needs to know the name and the email of the person that made the change, because, well, this is internet and that's how we work. We need to know who made the change and we need to have an email so we can contact the person. needs to have a timestamp so we know when the snapshot was taken, and it needs to have a message which describes what the commit is about. And the message is a quite critical part, because if you don't have good messages, then you don't really help people of getting advantage of version control system. Okay, of course, those are the metadata of the commit, and the actual changes are also stored in the commit. So maybe we could see here, for instance, this is a commit, this is the ID, this is the message. I just said here that I update the metadata for the 0.6.1 release. This is who I am, the author of the commit. And those are the changes over here. The two files that I had to change. The file called changelog, where I edit the changelog, and the file where I just changed the number of the version. And now, to finish this first part of the theory, I want to explain branching. And branching is pretty much what we saw before, this metro-like diversion of versions. So I hope you're kind of familiar with the notation I said before, the idea that the history of a project is basically a graph, and it's composed by nodes, which are the commits, and every commit knows the previous one. We have this notion of branches, and I should change that one. I will, I promise. Yeah, I know, I will. So the first one is A, the second one is B, the third one is C, the fourth one is D. And in that case, we have a branch which we will call main. Well, master in that case, I promise I will change it because, well, words matter. But anyway, for this example, we're going to call it master. This is one branch, okay? There's no diversion, there's nothing complicated happening. Now, someone wants to experiment over there, and they're like, okay, I'm going to start experimenting with adding some feature in my code. I'm not sure if I'm going to need it in the end, so let's just make a new branch, and they call that one branch. Okay, so now they make a new commit, they start implementing the feature, and that's the new branch. At that point, it means that I have the choice when I want to work in this project, and I can either keep working in the master, which is like the main branch, where I know I have stable code. That's the truth. That's the one that everybody accepts, that it's the good quality code. And one branch is just a branch where someone is experimenting with something, and they know why they do so. So they're going to keep working there, but they don't distract me. I mean, I can keep fixing a bug while someone else is working on a feature here without being aware of what they're doing there. Okay. So that's another branch. And then meanwhile, someone wants to fix a bug, of course. So they go back to master, and then they add this change over there. So that's how we create this diversion, those two branches of the graph. And as you see, E is the experimental feature that we said before. F is the bug fix that I just made. And those two are unaware of each other, of the changes that each other made. And I can always jump from one another. It's fine, right? As soon as I have something in my version control system, I can just say, well, I'm going to see what's happening with that feature. You can run there. Of course, the bug fix won't be there. And then I can jump back to the master version. Then the person that is working on the experimental thing can keep adding more and more commits with more changes. G and H in that case. Of course, you can always keep looking at how the arrows specifically only point to the previous one. So D doesn't have to be aware of how many commits have diverged of it. We only need to know the previous one. And then eventually someone's like, that feature works. Super cool. Let's have it in the master branch because we really needed that. And then at that point, we can have a merge. And when you have the merge is, if you see here, you had F, you had H, and then you have one new commit which is made and is composed of all the changes from this line and from that line. And at that point, I have both the bug fix and the new feature. And I hope that makes sense. We're going to see, I'm not sure if we're going to have enough time to do it today, but we're going to see how that works locally by the end of this course. And that's basically the ultimate way of doing things with version control systems. Yeah, that's good. So I suggest we take a coffee break if you don't mind. We started a bit late, so I suggest we make it short, like maybe be back at 12:15. Is that fine? Just 5 minutes, guys? Yes, okay. Whoever doesn't respond, silence means acceptance. Sure. Cool. Okay, so I guess I'll see you in 5 minutes and we'll talk more about Git there and the specifics. Okay. Meanwhile, please download Git if you haven't done so already. See you in 5 minutes. Okay, sorry for missing the questions, guys. So there are two questions. One is whether you can use source tree, and the other one's about the installation. So for the installation, yeah, I guess Andre's suggestion is it's kind of good. The Windows Explorer integration, you don't necessarily need it. It's only about, I think, right clicking anywhere in Windows Explorer, so you can open the Git window, let's say. If you don't need that, you don't have to have it there. Now, for the source tree, yes, source tree is a GUI on top of Git. So today we're going to see how things work with Git itself. Git itself is a command line software, so you have to type commands to do things. I can't pretend it's going to be necessarily easy, but it's definitely, especially if you get up in anything complicated, it's the most clear way of doing things. Now, if you want to use any other tools, there's so many out there. There's a GitHub software client, as they call it. Please don't use it. I don't know. I find it very complicated because when you want to do things with Git, you want to be clear about how things are happening. I mean, what we said before, what's the state of the repository, local repository, the remote repository. So the GitHub client is not good in my opinion because, I don't know, it's has its own terminology. It has a sync button. I'm not sure what sync means. So we're going to learn today all the commands of the Git command line. And there are good tools like source tree. Source tree is one of the good ones because they follow the same terminology. The add is add, more or less. Commit is commit. Push is push. Pull is pull. I mean, the same things that you type, you can push them in buttons. I will suggest a few GUI, but we've tried many different ones in the past, and we concluded this time it's better if we just do it command line because that's the best way of doing this. This is the official client, and yeah, it might be harder, but I think it's worth it. And if it's hard for you, you can go to source tree for the beginning. I've been using source tree at the beginning, and then I switched to command line, to be honest. So source tree is a good choice, but source tree is annoying because you have to make an account in Atlassian. What's the name of the company that they make it? And they give it for free, but you have to register, I think, and every year you have to renew the license or something like that. It's free, but still annoying that you have to give your email and stuff. So that's but the question of Pratyush, I'm sorry for killing your name, Pratyush. I'm Greek. I'm used to people killing my name as well. So. Yeah, that's because. So I'm not sure if I want to explain this now, but oh no. So that's a different option. Well, you can. I normally use the first option because I find it safer. Then you have you can always start using Git from the Git bus start menu item, and then you're safe. With the second option, it's supposed to be available also if you just start the command line or the PowerShell. So I don't know, you can go with whatever you want. I personally go with the first one because the first one builds a Unix-like environment. So it has also some other commands that you have in Unix, and I find it personally also safer because it's isolated, but you can go with whatever you want. If you want to use PowerShell, you should use the second option, as far as I know. Okay, I just saw Andre's suggestion about Vim. Yeah, so Clara said something about Vim yesterday. Vim is a beast of its own. It's a text editor, as Clara shortly demonstrated yesterday, and it's a way of editing the files in the command line. Not the best way of doing things, yes. I'm gonna show you eventually how to use it today. But if you don't want to mess with Vim, there's a way of changing the default editor to another one which is more normal, I would say. It's called Nano, and you don't have to do some weird things that we're going to see with Vim. But we're going to see about it like as we go. Okay, I don't know if they give you the option when you install on Windows, but you can definitely change it by changing the configuration file of Git. So, any other questions? I'm going to wait 5 seconds. 5, 4, 3, 2, 1. Nope. Good. So, let's go specifically to Git, because what I said so far, well, oops, Caroline or Caroline is typing. No, it should come installed with Git itself. Especially if you use Git Plus, it will definitely come with it. Not sure what's going to happen with the second change, with the second option that Bradley is showing. No, it should come with it. What it does basically, sometimes I think in Windows, it might identify that you have something like Node++, and it might actually use Notepad++, for instance, instead. So I think those guys, they make those installers clever enough, and they will pop up some editor. It doesn't matter if it's command line or something else. Could be Visual Studio Code, as Andrei says. I think on Windows, if you have Node++, it might show you that one. Let's see, as we go. I will also show you how to actually submit descriptions without having to use a text editor, to be honest. So let's not make things too complicated for today. So already 25. Yeah, 25 past 12. So let's move on, guys. Okay, hope that covers it. You can always make questions, of course. So I'm just trying to motivate you to make some. So Git, what is Git? Do you know Linus Torvalds? You're not here, so I can't see you. Well, Linus Torvalds is, if you know, the creator of Linux. And in 2005, he created Git. And why he created Git? Clara is typing. Well, so people are typing and I'm exactly. Yes. So, Linus Torvalds, if you are aware, he's kind of a peculiar guy. And anyway, so at first, Linux, if you know Linux, it's an operating system. It's open source, super cool. I have it one. So Linux was initially being managed as just simple patches sent through emails. There's a way of just getting the difference between two files and extracting a patch, and someone else can take it and then they can apply it to their code. So they would have changed patches through emails. Then they decided to try different version control systems, and of all of them, Linux have tried, I think, a lot. CVS, the one of the centralized that we said before, he hated with passion. We're gonna explain later on, and but they eventually ended up with someone which wasn't open source, but it was given for free. And I don't remember the name right now. Andre maybe remembers. It's not Mercurial. Never mind. So, but Linus liked it a lot. They were working, but there was some kind of controversy in the community and people were fighting. Well, that's what happens in every open source project. People are always fighting about stuff. And at some point they decided they couldn't go with that. I think the controversy is because it was closed source. And then they were like, Linus was like, I'm not going to use anything else if you don't want that one. So I'm going to make my own one. And he started building Git in 2005. It's that young, or I'm that old, but whatever. So basically, he just reverse engineered the one that they were using before. And so he set up these four objectives. Basically, he wanted to have fast performance. We had to deal with a lot of files. He wanted to take CVS, as I said before. CVS is one of the centralized systems, one of the oldest ones, and he wanted to take that as an example of how not to do things. So he said, if we are in doubt of how to do something, we look how CVS does it, and we do it the other way. Okay, so that's how much he did that. Yeah, so BitKeeper, that's the thing. The third one is that it should be distributed, as we said before. That was BitKeeper, how he was doing it. We actually, it was, I think, a controversy that they kind of reverse engineered how BitKeeper was working, whatever. And yeah, it should include very strong safeguards against corruption, either accidental or malicious. So one thing you should know, the same thing I've been taught about sailing. Well, no matter how hard you try, you have to really, really try hard to break your repository. Same applies for sailing. But anyways, so Git is a complicated thing, and many times you might think that you have messed up your repository in an irreversible state. That more often than not, that's not true. And many people are intimidated. But one thing that is good about Git is once something is inside there, it's in this bucket, once you've made a commit, losing the changes or breaking something is almost practically impossible. I mean, you have to really know what to do in order to break it. So, if you remember what we said before, just to add some more definitions, we said every commit has its ID. In case of Git, the ID is a hash. I think it's SHA-256. If you know what hashes are. If you don't know, hash is a mathematical function where basically you just get some big chunk of numbers or text or whatever, and it will always compute one number of a fixed size based on that. So you get, let's say, a huge text file, and then you compute this number, and no matter how big or how small the text is, this number is always going to have this specific size. And those hash functions, they have some attributes, which means that it's practically impossible that you can take two different text files and you will find the same number. Well, technically it's possible, but practically it never happens. Okay, so what Git does is it takes all the information about your commit, so the changes that you made, your name, everything, and the ID of the previous commit, and it makes a hash out of that. So one of the cool things is that this ID can also verify if this commit is actually valid or not. Okay. Can you see this number? No? Hope you can. So this is the hash. In this case, it doesn't matter if this is a hexadecimal number. You would see numbers and the letters A, B, C, D, E, and F. C, D, E, F. It doesn't really matter. That's how we refer to versions or commits. Okay. And the other one is that we have a current commit, which is called. Wow. Sorry, guys. I was showing the presentation. Sorry. So this is the hash. Okay, that's how it looks. That's also what you see here, for instance, right? This is the commit that I was showing before. Of course, you don't have to remember all those things. Normally, you just refer to like the first 5 or 6 digits, and that could be good enough. But anyways, so yeah, and the second term that you need to know is term of head. So the term of head, and that basically refers to the current commit. Now, current is a bit of a vague term, But think of it like head is always pointing towards the commit that you're going to build upon, right? So remember when we said before in this example that you are in D and then you make a new commit, E. So before you submit on E, D was your head. So that's the one that E is going to point as the previous one, okay? So head is, let's say, what I started working on, the version upon which I started working on, okay? So based on the things, and by the way, I want to apologize before because I forgot to change the names on these slides. So before I showed you the example with the master branch, we try to avoid this terminology because of, well, all the things that are happening in the world. And there's a huge wave of people that are changing from master to main. I did change in the break. So from now on, we don't refer to master, we refer to main as the default branch, let's say. So that's the same example with the branches that we saw before, but instead of A, B, C, etc., I would show you the first 7 digits of the ID, right? So this was the first commit, this was another commit, this was the last commit of main, and then we have another branch which has this and that commit. Okay. So 2 things here. I hope you understood the concept of branches before. One of the misconceptions about branches is that they are actually a whole line. So if you remember when we saw the metro line thing, you could think of like one branch is the blue line, the other branch is the red line here. But that's a bit confusing and it's a bit vague, right? Why isn't, I mean, what's a branch in this case? Is the red branch just the part from here to there, or is it like from here to there and then here and then there? So, well, Git how it does it, it just doesn't care, let's say, right? So every branch is just a little tag, a little label that is the last commit of your history. So all you have to say is like, the last time I changed something, I was here. And then based on that notion that every commit knows the previous one, I can just propagate back to history and then I can build this history on the fly. That's how it actually works. You don't have to remember that main was at some point somewhere in history. All you need to know is that it ends here, and then you can build the graph by just following those little pointers over here. Okay, that's how it works. That's why you see me pointing out main with this point to this commit and new feature with this point to that commit, because that's exactly how Git knows them. It just knows that new feature is this commit. And well, what's the history of new feature? Well, it just follows the arrows back. Okay. Now, on top of that, we now have the head, and the head is a special, we can think of it as a special branch, let's say. It's a special tag that marks that this was where I started working on. So I started working from here, I made some change in my Python file. Now the head and my workspace have some changes, and we're going to see how we're going to deal with that later on. But that's the whole idea, okay? Well, that's of course overwhelming. These are all the commands that you are going to have to learn. But what's kind of important here is, well, remember how we said the workspace or working directory? We know what it is, right? I said it's a folder with the actual files that you have. Then you have the repository. So we said it's a big packet with all the information. The remote, I think we're going to better explain that on Friday, but it's like for the remote is another repository with which the repository, our local repository needs to exchange information. We're going to deal with that on Friday. And now we need to understand the context of the index, right? Forget about all the commands over there and just focus on the fact that we have the workspace, the index, the repository, and maybe the remote. So the index or stage, it has a dual name. sorry. So the index or stage is the intermediate step where we mark what we want to change. So the typical way of doing things is, well, I start from something that is normally the same as the last commit I'm working on, the head, as we said before, and I want to make a change. Let's say I just want to make it fine. Then now my workspace, as I change that, my workspace is now different from the head, right? Now Git is going to ignore that until I specifically mark this change as something that I want to commit. Because sometimes you might have multiple files and multiple changes in files, and you might not want to submit all of them. Because the point is that when you make a new commit, this is something finished. It's a finished product that other people should be able to work with in real life, right? So that's why we have the stage area, the index, as it's shown here. And I'm sorry for the dual meaning, but I think they changed the terminology at some point. Here is index. I think nowadays it's more called stage area, staging area, or stage. Doesn't really matter. So the workflow is like this. I start from what I had in head. I make my change. I add the change to the staging area. That way Git knows that I'm going to commit something. I keep adding stuff to the staging area as soon as I have more changes. And when I'm done, the staging area should be like the new commit as I want it to be. And then I will commit it and I will add it to the big bucket with all the histories. So at that point, I'm going to add the description, and it's going to take all the information. It's going to compute the ID and everything. And then it's going to end up in the repository, and it's going to be added to the graph that we said before. Okay. So we have the head, which is the last commit, we have the staging area, and then we have the workspace. So let's start looking at actual commands. Hopefully you'll have Git one way or another installed. If you have macOS, I think it works out of the box. Please, if you have macOS, start terminal. I'm using a specific terminal which is called iterm. You don't have to use that. Let me know if you don't, if you have an issue with Git, but I think it comes with macOS. Anyway, so it should be fine. And we're going to start by making an empty repository, just an empty bucket where we're going to work with, okay? And that's the command Git Init, okay? So here's my terminal, and I'm going to make a new project, okay, test project. Yes, could be Git CMD. I think there's a Git bash option, whatever works for you. Git bash is going to pretty much fake Unix environment in your Windows. It's not Linux specifically, but it's going to fake Linux environment. Okay. So I made this folder. So if you're in Windows, you should use the commands of Windows, which are different. That's why I would prefer if you would use Windows subsystem for Linux, or if you use Git bash, you can use the exact same commands as I use. Okay, yeah. Let me make things bigger. Is that good enough? So I made a folder. In my case, I called it test project, whatever. You can call it whatever you want. If you have Windows, I think the command is md. Okay, and then I'm gonna change directory, and I'm gonna go into that one. Those are the commands that you saw yesterday with Clara. So this is supposedly the project I wanna work with. Okay, doesn't matter how I'm gonna work. I'm always going to have a terminal, and you're welcome. Thanks for notifying. If you want to work with the terminal, you're just going to have the terminal open, and then you're going to do all the commands that we're going to show through the terminal. Otherwise, you can use something like source tree, as we said, or there's some other things like sublime merge and things like that to work with. Okay. So this is the project I want to work with. If you want, you could use Visual Studio Code at this point to just make example files. Let's do that for now. So I'm starting Visual Studio Code, and of course I have nothing so far. So I'm going to make a new file, which is the main.py. Let's make a Python project, why not? And I'm going to make a hello world example. Yeah. But this is small as well. Okay. So I made this file, main.py. I guess if I ls, if I list the content of the directory, then I will see main.py. If you remember the command that Clara gave you yesterday, ls does la, we also give me the permissions of that, right? So this is like read, write, execute. I don't have execute, read, write, execute. This is for the group, this is for the others. Never mind. So anyway, let's run that. Ooh, it works. Prints hello world. Am I a great programmer or not? Yes, I am. Guillermo wants to ask something. I guess you mean VS Code, Guillermo. Yes, you don't specifically have to make a new project. I mean, you just make Python files and then you run them, okay? So you can just right-click new file or file new file, and then as soon as you name your file .py, whatever name you want to give it, yeah, that's fine. Then from the terminal you can just type Python main.py. Well, on Windows again, see if you had Windows subsystem for Linux, you would have Python. Otherwise, on Windows you would have to install Python. Doesn't really matter because, well, whether you run it or not doesn't make any difference. It could be just a text file, a LaTeX file. Git doesn't really care about what kind of language you use, okay? Just looks for text files and oh, no, sorry. Just, yeah, my mistake. I just typed code those and the dot, which opened Visual Studio in my folder. Yes, of course. My mistake, you have to go to File Open, and then you have to find the specific folder that you just created, which is going to be empty, and then you're going to make the file. So, yeah, apologies for that. Okay. I see Clara typing. We'll make some notes. No, Clara stopped typing. It's something I want to ask you guys towards the end, so that's why I'm keeping notes, because I will forget. Okay, so Doberzon. You could see the full path of your new project in if you type pwd if you are in a Unix environment, if you have Mac OS. Okay, if you're on Windows, I assume that this folder is either in the home folder. So if you have Windows Explorer, you can it will have a folder with the name of your username. Okay, that's cool. So Andre says that pwd works, so I guess you can type pwd and then you can see the path and then you know where the folder is. Let me know if that works for you guys. Yeah, if you're in Ubuntu, then it's definitely just the home folder when you start the terminal. So Andre's typing. Lars, have you find it as well? Yeah, so as Andre says, will that work for Windows? I'm not sure, but for sure it's going to work with Mac OS and Linux. You can just type code and then a dot, and that will open Visual Studio Code in the current folder, so you don't really have to care about where it is. Although it would be nice to know where all the things that we're going to make are. Okay. Yeah, you can also do this, as Clara suggests. Um, not, oops, does it work here? Never mind. So Luis, code should work out of the box, I think, because it should be the name of the executable. So you don't really have to, you shouldn't have to change your pass profile unless you just downloaded Visual Studio Code somewhere in your home folder and you didn't install it through some repository. But yes, well, it should work for both, all those commands. So in fact, in Windows Subsystem for Linux, it might be a bit more complicated. So I hope Lars can have found it. Hopefully it worked for you. I'm gonna move on, and if we have more things we figure out, okay? So at this point, let's start investigating Git. So how do we run Git? We just run Git, right? That's Git. It's a command line tool. You just type it, and then you have to say what you want to do with Git. So if you don't say it, it's just going to spit a help message, and in that case, it shows how to work. So just to make sure that it works for you, you're going to do something like git test version. So you see the version, or of course just git, and it will show you the help message. Okay. So those are all the commands. We're going to go through them with the presentation anyway, most of them. Is it going to work? What Clara suggested? Yeah, I guess so. So that's one way of doing it. In my case, I use the tilde. I think that's how it's called. The symbol, that's home. I'm not sure if it's going to work for Windows. For Windows, you could probably use something like users, I think. If you are on Windows, I think if you go to see users, your username, whatever it is, in my case, it would have been with the last years. I think that's the folder that you should start with. So probably inside there, there's a test project. Otherwise, it might be in the documents folder or my documents or how it's called on Windows. Okay. Yes, so the tilde is the home folder, right? Or in other words, in my case, this is home. Well, no, this is, if you are on Linux, this is /home/ your username, right? So in Mac OS, this is /users/ your username again, okay? But if you don't want to type the whole thing, you just use tilde and that's the same, okay? I was already in a folder called temp inside, so I do everything there. So hopefully everyone has found a folder or they have Visual Studio code open over there. So if you do the ls, you would see the main.py file, okay? Now, if you have Python installed, you can actually run the Python file. It doesn't really matter. You don't even have to have a Python file. You can just do it with a text file. Maybe we should do it with a text file. Doesn't really matter, okay? Now, if I do Git status, we're going to see this command later on, but basically Git status is going to tell us what is the status of the Git repository, because the repository is also stored in the folder. So we said the folder, so test project in our case is the workspace, which is partly true, but it also contains the repository. It's stored in a hidden folder somewhere, so you don't mess with it. But basically, everything else except for this folder, which contains all the information, all the big bucket with all the metadata, the versioning history of our project, everything else is the workspace. And that folder is the repository, right? And at that point, I'm only working with a local repository. Now I don't have a repository. That's why if I say git status, if I ask the status of the repository, what I'm getting is a fatal, not a Git repository or any of the parent directories, because it's going to look at outside of the current folder to see if the parent folder has a Git repository. Okay, so what I need to do is I need to make a new empty repository, and this is the command git init. Right? This is going to initialize a very simple empty local repository. I'm going to press enter, and there it is. It says initialize empty Git repository, and it's going to give me all the path, and then it's going to tell me what's the folder of that. So all the information that we said before, the graph and the information about all the information about all the history of the project is in this .git folder. If you know anything about Unix, dot at the beginning of the file means that this file is hidden. I mean, on Windows, you have to go to the properties and then check some checkbox that says hidden. On Unix systems like Mac OS and Linux, this is implied by the name if you add a dot at the beginning. So if I do ls, I don't see any .git folders. That's because ls by default won't show me hidden folders. But if I add the A flag, which A means all, then I'm going to see .git over there. See that? And it's better if I do the LA, which is also going to list it. And there it is. This is a directory, as Clara said yesterday as well. So D says that. Also the color highlights that. And this folder actually, if I look inside that, I can do that with ls.git, has certain information. You see head is, for instance, a file that contains what is the last commit that I worked with, There's a configuration file, some descriptions, and the object basically is all the things. Refs has information about the branches, etc. You don't really have to know that. All you need to know is that there's a .git folder and that's the whole repository. Well, if you delete that, remember how I said you cannot screw things up? Well, if you delete that, well, you lost it. Hopefully you have a copy somewhere in GitHub, but if you only have it locally and you delete that folder, yes, then in that case you lost the whole history of the project. So, Doberzone Zoom, or Zone, is it Dutch? Sorry, whatever. Made a very nice question. So probably in my case, if I say now Git Status, it will say on branch main. And in my case, because I have those extra tools, it always shows the name of the, sorry, it always shows the active, the name of the active branch in the beginning of the line. You probably, because the default setting is master, you probably got master instead. Well, that's because this is a relatively new change. You can keep working with master for now, but otherwise you can change the configuration of Git by going here in Git Config. Yes, exactly. So everyone is going to have master more often than not, because it was the latest version that actually made main as the default. I think came on July, or maybe it didn't make it. So you can actually make it, you can force it to have the default as main here if you add those two lines. But, well, sorry. This is Vim, by the way. Proteus asks if it is like Gedit. No, Gedit is a GUI tool. Vim is a command line tool. So as you said, as you saw right now. So if I vim main.py, then I can edit the same file that I have here on Visual Studio Code from the command line. But Vim is a bit weird in the sense that right now, if I type, I cannot do anything. I can only type as soon as I press the key I. Yes. So Vim or Nano are the two most common text editors. You can use Nano as well. It's slightly closer to what you would expect, I guess, because that one you just move around with the arrows and then whatever you type is there, and then you can just backspace. And then when you want to go, you can just press Control and X, and then yes. But never mind. Okay, Andre, yeah, that's all my Zas, and well, I will let you know about the rest later on. Okay, I'm gonna type that. I'm gonna add this as a note towards the end. But yeah, that's all my Zas, and there's a specific theme of all my Zas. But if you download all my Zas, it will always show you, I think, the current branch. Okay, now. So, as I said, we just made an empty repository, and I say Git status, and it says that I am on branch main. There are no commits yet. And it says, well, that's okay, Guillermo. Let's leave that for now. This is just about editing files from the terminal, and we don't have enough time now anyways. And this is not necessarily important. Oh, so you're using PowerShell. Yeah, that makes sense. You won't have those things in the PowerShell. It might be the case that on Windows you have a tool called Edit. Let's not focus on that right now. Okay. My suggestion is for the next course you all have one Windows subsystem for Linux, or you use the Git Bash. At least then we all use the same commands, and it's easier for everyone. I hope that's okay. Otherwise, you have to find a way to install Nano in Vim or PowerShell. But I think it would be useful for you also to switch the Windows subsystem for Linux. It's getting more and more popular amongst developers. And I don't know, I find it more practical for general users. So let's move on quickly. So as I said, it says we're on branch main. You should be on branch master. That's okay. I've just changed mine because I wanted to be more sensitive about some issues. So I can show you how to change it later on. Untracked files, that's the interesting stuff, right? So remember what I said before, that there's a staging area and you have to mark specifically what you want to add. Here it says untracked files. That means that Git doesn't care about what main.py does because I've never added it before. And as soon as I haven't added a file, Git assumes that this is not a file that I want to keep track of. Okay. So sorry, I got distracted. Sorry for that. So as I said before, Git, if you haven't marked any specific file before, it won't care. Okay, it will just ignore it. Why does it do that? It does so because many times you might have code and you might have configuration files next to it. Okay, happens quite often because, well, you might have something like a database, or you might have some source files that you want the script to run, right? And different developers that collaborate will have different configurations, or even yourself, if you have the same project on your laptop and then desktop, let's say, then the laptop maybe has different database or different path for some files than the other ones, right? So many times we don't want to keep track of all the files in the folder, in the workspace. So that's why with Git, we specifically mark the files that we want to be tracked, okay? So let's go back to the presentation to quickly follow. So we just made an empty repository. For me, it should have an empty main branch with nothing. For you, it should have an empty master branch with nothing. That's how you start from the top. When you had nothing before, that's the first time you want to make a project, okay? But if you want to work with an existing project that is always already there in GitHub or something, you want to collaborate with someone, and then someone else made the project for you, then there's the Git Clone Command. We're going to see this command more on Friday, but the idea is that you say Git clone, and then you get an address which is given by GitHub in that case. And what this is going to do is that instead of just having an empty repository, we'll just download all the information from that repository, from the GitHub project. So it's going to go to GitHub and then grab this huge .git folder. Apparently, I assume it's going to be huge if it's a big project, and download it to your computer. And then from now on, you have a local copy of that, and then you can keep working. Okay. Git status we just saw. It just shows you what's the current branch and what is the difference of the branch with the remote. So if you, we're going to talk about remotes on Friday, but it's going to tell you, for instance, if you have a GitHub project with which your local project is having a difference, it's going to tell you, for instance, that my main is maybe 3 commits ahead of the main branch on GitHub, let's say, right? Because I have set up GitHub, let's say, somehow to be tracked. We're going to see some things about that on Friday. Shows what it states. Now we didn't have anything changed. It shows the changes of the not changed files, of the not staged files. So if I have a file that I've changed and I'm tracking, then it's going to notify me about those. And then it's going to show me the untracked files. So in that case, we only have untracked files. We would never stage everything. We never committed anything, so we only have untracked files main.py. That's why we get this untracked files list, and then the only entry over there is main.py. Okay. So let's start staging things so we can commit, right? Remember what I said, we have the workspace, we need to take the changes that we have in the workspace, we will need to stage them, and then when we add everything that we want to be committed in the stage, then we're going to commit, okay? So let's do that. Well, typical way of doing that. Sorry. So we're going to do Git status. That's assuming that we haven't done so before, and then we're going to see, okay, main.py is not ranked. We say git add main.py. Okay, so that way, what I'm saying is, you know this file that you don't track anymore, or even if it just had changes and you've been tracking before, well, add it to the stage. Okay, now you see I get this plus symbol. You won't have that. This is part of the Omagesh environment. I'm going to post some information about it after the course. It's pretty cool. You can have it if you have Mac OS or Linux or Windows subsystem for Linux. But anyways, so if I now say Git status, then what I see is instead of saying untracked files, it says changes to be committed, right? So it says if I now ask Git to make a new commit, to make a new snapshot, it says that it's going to have main.py, and this is going to be a new file because it has never seen this before. Okay? If I had other files and I also wanted to add those as well, I would have to do the same. I would have to say git add, let's say, second.py if I had another file, let's say. Okay? For now, we only have one, so that's fine. You can also use more arbitrary definitions over there. So you can say git add dot. Dot always stands for the current directory. In that case, Git is going to look into all the files in this directory, and if there are untracked files, or if there are files with changes in the directory, it will automatically add them. Or if I had a folder in my project, which is called, let's say, src, if only I had one, then I could say git add src dash, and that would add any file that is inside the folder, ignoring anything outside of that. Okay, those are some things that you can figure out on your own later on. Okay, for now, main.py is in the staging area, so let's see how that works. Let's see that notation that we had before and what happened. So we have a repository, an example repository. This is not our specific case, but let's say in this example we had two commits. That was the first one, that was the last one, and here is main, and this is the head, of course, right? Head is the last commit upon which we work with. This is the index or the staging area, you call it as you want. It's empty for now, and this is the working space, right? And we have a file.txt. In our case, this was called main.py. And as soon as I make it from Visual Studio, from Vim, whatever editor I used, it's in the workspace. That's something that happened outside of the world of Git, right? With git add, what Git did is that it copied the whole file in the staging area. Now, you might be thinking that Git is keeping track of the changes. No, it doesn't. It just, every time you say git add, basically Git is going to copy the whole file and going to put it in the staging area. If that's an existing file which has changes, what it's going to do is going to replace the file that was there before. Okay, so if I had the previous version of main.py, I change it in the workspace, and with git.add, it's going to just take the new version and put it on top of that, right? And now the staging area has the new version of the file and it's ready to be committed. And how do I commit? With the Git Commit Command. Okay, that's going to make a new commit, and it's going to take my name and my email and the message that I'm going to provide. Now, in your case, you want the name and the email should be configured somewhere in the configuration. And if you don't have that, Git is probably going to ask you for that. I'm gonna try to do something. Just don't follow what I'm going to do, please, because I just want to replicate what's going to happen in your case. Okay, so don't do this command. So if I do a git commit, well, oh, still took it from somewhere else. Never mind. So simple git commit, we just try to make the staging area, the status of the staging area, a new commit, right? So it's going to take the name and the email, which should be somewhere in the configuration file. If it's not, I guess you're going to get an error, and we're going to fix that together. And if you don't provide a message, it's going to open Vim, as we said before, or Nano, or it could be something like not++. You can actually change that to the configuration, and it's going to open that and wait for you to type a message there. Now, in order to avoid that issue for now, we can just add -m, which basically means message, and add a simple message, in our case, initial commit. Okay, that way, thank you, 2%. That's exactly what you're going to get. We're going to fix that. So that's how you can do this without having to open Vim or Nano or anything, but it kind of forces you to only have one message of one line. Okay. Now, you saw what Doberzoon said. You probably have the same issue if you try to do a simple git commit. So what you need to do is you need to type those two commands that it gives you over there. So user.email, and then you should type your email over there, right? That would be mine. And then you type enter. And then you need to run this once again with git config ---- global user.name, and then your name. In my case, that would be Github. Okay. Now keep in mind that email doesn't have to be the same as you have in GitHub. If you happen to have a GitHub account or anything, it's just an email that is added in the metadata of the commit. Okay, so that someone that finds a commit knows how to contact you. If you run those two commands, then your configuration should be fine, and then you could do a git commit. Well, if it did work, Luis, do you have Mac OS? I think in my case, because I tried to delete my configuration, I think it took the name from my user account and tried to imply an email from some information from the system. Okay, so if let's do the commit for now. After you do the two global commands that I said before, it's also there at the print screen from Doberzoon. Git commit -m, and then you put the message inside the double quote. Normally, the first message is always the initial commit. That's what we say, and it should say something like that. Okay. So now in that case, if I say git status, it says that I'm on branch main and there's nothing to commit, and the working key is clean. So the workspace is clean, there's nothing new, nothing really happening. And now, to also answer Luis's question, we don't have the time for the explanation. Yeah, I don't have the command here. But when you want to see the history, you can just say git log, okay? And that is going to show you all the commits from the one that you are towards the end. In our case, we will only have one commit, hopefully, right? So if it succeeded, Luis, then if you type git log, you will see the information of the commit, right? So this is the ID. It says that also the main branch ends here, and that this is also the head. It means that if I do something new, then the previous commit of the new one is going to be that one. Okay. It gives me the author, my name, and my email, as I have them in the configuration, and you should have them in your configuration. And in your case, Luis, I guess you'll have to figure out what the system came up with, and the date of the commit. And then is the message, which is initial commit in our case. Okay, I hope that makes sense. If your email, you can always change the email with the two commands that are there: git config -- global user.email and all the things you can see on the person's print screen. Even if there is already a value, but this commit will always remain with the information that it had the time that you committed. Okay, I guess we are out of time because it's quarter-past 1. So I'm gonna have to finish the class for now. We didn't do as much as I wanted to, but I think we at least followed everything, and I hope it worked for you guys. On Friday, we're gonna try to do things faster. We're gonna work the whole 2 hours anyways. So before I finish, there's something I want to ask you, and that is whether you are fine with, whether you prefer that next time we use the voice channel of Discord. So I'm gonna still streaming through Twitch, but if it helps you, instead of typing, you can be on the voice channel, and then you can make questions by using your microphone. If you think that's better, please let me know. Otherwise, we keep doing it like that. I just think it's faster if we just talk, and it's easier also for me. It's probably less awkward. Are there any questions? Anything that we can quickly address? Yes, Ivan shows how. So the config actually is just one file which should be in your local folder. It's called .git config. Not sure where it is in Windows. So this is the file, and then if you open the file, you will probably see something like that. This is the user section, and you have the name and the email, right? There are some other preferences here that you probably won't have, because those are probably things that I've added at some point. You have aliases, that's something you don't care. But this is also the change that you might want to have if you want to make sure that every time you make a new Git repository, instead of master, you get a main branch as the default. Seeing more people typing, so I'm not going to close that. That's actually how you can do it from the command line if you want to set main as your default branch. So git config -- global init default branch main. So you can either change the config yourself with the text editor somewhere. You can use Visual Studio Code, Notepad++, whatever, as soon as you find it in your home folder somewhere. Or you can type this command: git config -- global init default branch, and then double quote and main to set the main as the default branch. I think at the point I want to dismiss you. The difference is, yeah, I haven't explained what's the terminal that I'm using. You can leave if you want, but for those that want to stay and see, let me switch back to the view. So what the terminal is not necessarily the most important aspect. I'm using iterm2 for on macOS. But basically the environment that I have is the shell. So I have something similar also here in the original terminal, if you see, the same colors. Well, the letters are, but whatever. And if I go to that, you see I still have those things. If you want to have those nice things, you can have them anywhere with any terminal software. But you have to have a Linux or Bash environment, so you should either have Git Bash, or you should have Windows Subsystem for Linux, or in Linux or macOS. It's going to work out of the box. You have to go to omyzsh. That's the address, omyzsh, and yeah, it's pretty straightforward about how to install it. You just run this thing over there, and you're gonna have another theme. If you're interested into which theme I'm using, I think mine is called Agnostic. It will have a ZSH theme somewhere, and yeah, that's the one that I'm using. And it comes pre-installed. omyzsh is cool. It has certain plugins. Like if you've noticed, sometimes when I type, you get some autocomplete, and those are things that you can add as plugins as well. And all the colors and stuff, you can also add them as plugins. I hope that helped. Let me know if you have more questions. Send to Git help anytime if you have any questions. You might also send me an email if you need more, or even a personal message. I don't mind. If you want to ask me something in person. And yeah, I guess that was it. I'm gonna see you on Friday at 10:45, if I'm not mistaken. And yeah, thank you very much. Bye, guys.